Welcome to lesson 8.4, Areas of Triangles. So, as I mentioned in our lesson about the fundamental properties of area, most of the figures that we're looking at in this unit have their area formulas derived from the area of a rectangle being length times width, base times height, whatever you want to call it. So the main idea for today's lesson is that the area of right triangles and all triangles is deduced from the area of a rectangle. So for example there, we'll begin with the right triangle area formula, which says the area for a right triangle is 1/2 the product of the lengths of its legs. Now remember, the legs are the two sides in a right triangle that are meeting at 90 degrees, or the perpendicular. The side opposite the 90-degree angle is our hypotenuse. So we don't care about the hypotenuse, we care about the two legs. So where did this idea come from that this is the area of a triangle? Well, if we just simply look at a rectangle, if I labeled one side H and the other side B, and I cut it along its diagonal, I end up with two right triangles. So if we think about that, the area of the original rectangle is base times height. So the area of each triangle would be 1/2 of that base times height. So that's where the idea of area of a triangle comes from, and in this case, specific to a right triangle. So what we look at in example 1 here is we care about our legs of the triangle. So our legs are the 9 centimeters and the 12 centimeters, the two sides that meet at 90 degrees. So our area is 1/2 multiplied by 12 multiplied by 9. So in other words, 1/2 of 12 is 6. 6 times 9 is 54 centimeters squared. And always remember, our units are squared or to the second power. So what if we don't always have right triangles? Well, that's where we get into the idea of an altitude of a triangle. And the altitude of a triangle is the perpendicular segment from a vertex to the line containing the opposite side. An altitude may lie inside, outside, or on the side of a triangle. The length of that altitude is called the height of the triangle with that base. So the side that it hits would be the base. So we're going from a vertex to the line containing the opposite side, and where it meets at 90 degrees, being the perpendicular segment, we would draw on that segment, and that is the height of the triangle. So if we look at triangle ABC here, it is an obtuse triangle. Now, the altitude, if we draw it in, starting at vertex C, opposite side AB has to meet at 90 degrees, would be the segment CD here. So the base of this triangle would be AB, height would be CD. And our next one, actually, sorry, not obtuse, that's an acute triangle. My brain's shutting down on me. Here's our obtuse triangle. Triangle ABC again. Now in this case, to draw the altitude from C, it has to meet AB at 90 degrees. That's not possible to do within the triangle. So our altitude, CD, gets drawn outside of the original triangle. And then we just have to slightly extend the side AB to look at the line it lies on to see where they connect. So the height of this triangle still is CD, the base is AB. And then in our last one, we have, again, triangle ABC, which in this case is a right triangle. So our altitude, CD, is the same as segment CA. So our height or altitude would be CA or CD, same exact segment, and the base here would be AB. So we draw on altitudes to be able to visualize the height of a triangle. The key is realizing that base and height have to meet at 90 degrees. Then we get to our triangle area formula. So we already looked at right triangles. Now the triangle area formula is the area of a triangle is half the product of the length of a side, so the base, and the altitude height to that side. So we have our formula for area of a triangle is 1/2 h times b, or because it's all multiplication, doesn't matter the order, 1/2 b times h. So I always think of it as 1/2 multiplied by base multiplied by height. But the key is that the base and the height, misspelling there, should be a t, base and the height meet at 90 degrees, so base and height are perpendicular. So for example 2, we have find the area of each triangle. So right away we're looking at triangle PST here, and in this case our altitude or height is outside the triangle, drawn here, which would be 4. Our base, even though they have to extend ST to connect it with that, our base is still just that original length of 6. So it's 1/2 6 times 4, giving us 12 square units. In the next middle triangle, again, triangle SPT, our height is drawn here on the interior of 6. Our base is the whole segment ST of 10. So area is 1/2 6 times 10, or 30 square units. And then for SPT, our last one, it's a right triangle. So I care about the two legs, 10.2 and 13.6. So our area is 1/2 multiplied by 10.2 multiplied by 13.6. So 69.36 square units. Then looking at our final example for areas of triangle lesson, it asks us to find the area of each triangle in the figure at the right. So we have many triangles drawn on this coordinate plane. So we'll look at triangle ABD to start. So triangle A to B to D. So when we're looking at that triangle, what we care about is the height, which would be segment AC, because AC meets BD at 90 degrees. So our height would be AC, our base is BD. So our area is 1/2 AC times BD. AC is 6 units long. BD is 7 units long. So 1/2 multiplied by 6 multiplied by 7 is 21 square units. Part B, A equals 1/2 AC times CD. Because in this case, we're looking at triangle ACD. So triangle ACD, this little one right here in the middle. Well, in this case, our height would be AC, and our base is CD. So AC is 6 units, CD is 2, so 1/2 of 6 times 2 is 6 square units. Part C, we're looking at triangle ADE. So A here to D to E, so this little slanted triangle on the right. And in this case, our height is still segment AC, because it meets the base at 90 degrees. So it's 1/2 AC multiplied by, in this case, our base of DE. So 1/2 of 6 times 3 gives us 9 square units. And then our last one, triangle ABE, so the large triangle here. So in triangle ABE, again, our height is still AC, and the base is the distance from B to E, that whole segment. So AC being 6, BE being 10, and half of that, so 6 times 10 is 60, half of that is 30. So area of that triangle is 30 square units. So again, the main idea for this lesson can be simplified into this triangle area formula, which states area of a triangle is 1/2 multiplied by base multiplied by height, But the key to all of this is making sure that you remember the base and height are the ones that are perpendicular to each other or meet at 90 degrees. So in order to find the height, you may have to draw in the altitude from a vertex to be perpendicular to the other side. And if you need help with the drawing of the altitudes, come see me and I can easily show you how to do that using just your protractor and a pencil.